This is my 7th video lesson for Unit 13. In this lesson, we'll be analyzing titration. Go to page 31 in the class packet. In the previous lesson, we talked about neutralization. In this lesson, we'll focus on figuring out the amount of volume or concentration needed to neutralize an acid or base. Let's look at this example. We have 100 mL of 1 molar HCl. How much volume would we need to neutralize it with 2 molar NaOH? So in this lesson, we'll figure out how to solve these calculations. Learning target. At the end of the lesson, I'll be able to determine the amount and concentration of an acid or base needed to neutralize in a titration. Homework B number 7, which will be a Junipod based off this lesson. There will be a quiz Junipod on PowerPoints 4, 5, 6, 7. Titration is a technique used in lab to determine the unknown concentration of either an acid or base by a neutralization reaction. An indicator is needed in a titration reaction so you can tell when the acid or base is neutralized. Here's the setup for a titration reaction. Analyte is a solution with the unknown concentration but a known volume. So in a titration experiment, we focus on figuring out the concentration of the analyte. The titrant is a solution with known concentration. We will figure out the volume of the titrant in the titration experiment. The titrant and the analyte can either be the acid or base. If the analyte's the acid, then titrant is the base. If titrant's the acid, then analyte is the base. The titrant is added to a graduated glass tube known as the Buret, and throughout the titration experiment, the titrant solution is titrated or added slowly into the analyte solution until there's a color change. Once there's a color change, the analyte is neutralized and the titration experiment is complete. The equivalence point is when it is neutralized, when the moles of the titrant is equal to the moles of the analyte. pH is 7 if it's a strong acid and strong base titration. The endpoint is something that we can observe during the titration experiment, while equivalence point is something that we calculate during the titration experiment. In theory, the endpoint should be equal to the equivalence point. Here's an example of a titration experiment near the endpoint, at the endpoint, and past the endpoint. Typically, you want your color change to be as light as possible. Now we're going to go over how to read a Buret. A Buret has markings. The markings are facing the opposite direction of a graduated cylinder. In a Buret, the numbers are increasing from top to bottom, while in a graduated cylinder, they are increasing from bottom to top. The Buret holds the titrant solution. The stopcock is a valve that allows the titrant solution to flow out through the bottom. To figure out the volume of the titrant that is titrated or flows out the bottom, we need two measurements. The first one is the initial volume. In this example, it is 5 milliliters. Once we record the initial volume, we can open the valve and start titrating. Once you finish titrating, you have to record the final volume. In this example, the final volume is 21 milliliters. To figure out the total volume titrated or added to the analyte, it is final volume minus initial volume. So in this example, it will be 21 minus 5, which is 16 milliliters that we added into the analyte. Just remember, the initial volume will be smaller than the final volume. Let's look at these examples. In the first one, the initial volume is 3 milliliters. The final volume is 7 milliliters. So the total volume added is 4. Try to do the rest of the questions yourself. Pause the video and resume as completed. Here are the answers. We're now going to go over the details and the procedure of a titration experiment and draw a titration curve. Titration curve is a graphical representation of the pH of a solution during a titration experiment. So here's your setup. Here we have a Buret. We're going to fill the Buret with 2 molar NaOH, which is a base and is a titrant in this experiment. The analyte will be HCl, which is an acid, and in this experiment, we're trying to figure out the molarity of HCl. we're going to add 100 mLs of HCl into this flask. HCl is highlighted gray. Next, we're going to add the indicator, which is phenolphthalein. Now the setup is complete and we can begin the experiment. We will be recording the pH of the solution inside the flask. So currently, the pH is less than 7 because HCl is an acid. Before we can start adding the titrant to the analyte, we must record the initial volume. Once we record it, we can start adding the titrant drop by drop. We're going to add 1 drop at a time. Notice a very small part of the solution became pink but disappeared. Once the solution becomes permanently pink, you have reached the endpoint and you're done with the experiment. Since we added 1 drop of base, the pH of the solution will be greater. Now we're going to add another drop of base into the solution. The pH again will increase. Now let's add a bunch of drops into the solution. The pH again will increase. As we're approaching the endpoint, we can slow down and add drop by drop again so we don't pass the endpoint. Notice that the solution became pink and we reached the endpoint. Since the solution became pink, the pH must be greater than 7 because if you look at table M, phenolphthalein turns pink when the pH is 8 or greater. Now that we reached the endpoint, we are done with the titration experiment. We have to record the final volume. With the final volume, we can determine the volume of 2 molar NaOH that was used to neutralize 100 mLs of unknown molarity of HCl. Using this information, we can calculate the molarity of HCl. But before we do that, let's finish up the titration curve. Let's add more base to the solution. By adding more base, the pH of the solution in the flask will increase. Now let's connect the dots. And this is our titration curve. The equivalence point is in the middle of the steep slope. So what is the pH at the equivalence point? It is 7 for a strong acid and strong base titration. To figure out the unknown molarity of the acid, we're going to use the equation on table T on your reference table. Molarity of the acid times the volume of the acid gives you the molarity of the base times the volume of the base. Before we did the titration experiment, we knew the volume of the acid and the molarity of the base. During the titration experiment, we determined the volume of the base, and now using this equation, we can solve for the molarity of the acid. Here are different types of titration curves. In the first one, we're adding a strong base to a strong acid. At the equivalence point, the pH is 7. In the next one, we're adding a strong acid to a strong base. At the equivalence point, the pH is also 7 because both of these are strong acid and strong base titration. On the Regents, this is the only scenario that you must know. Here is a weak acid to a strong base scenario. At the equivalence point, the pH is greater than 7 because you're forming a basic salt during the neutralization reaction. The next one, you're adding a weak base to a strong acid. At the equivalence point, the pH will be less than 7 because you're forming an acidic salt during the neutralization reaction. The last scenario is polyprotic, and there is multiple equivalence points. Now we're going to go over the calculations involved in titration. Let's go to the equation on table T on your reference table. At neutralization, moles of acid is equal to moles of base. We know molarity is equal to moles of solute over liters of solution. If we rearrange this equation, we get moles is equal to molarity times volume. If we substitute this equation into this one, we can see that moles of acid is equal to moles of base at neutralization. Let's look at some examples. A 10 milliliter sample of hydrochloric acid neutralizes 15 mLs of 0.4 molar solution of NaOH. What is the molarity of the hydrochloric acid? So you have to use the equation on table T on your reference table. In this question, we're solving for the molarity of hydrochloric acid, which is the variable Ma. We're given every other variable, so let's plug into the equation. Using our calculator, we got 0.6 molar of acid. You don't have to convert milliliters to liters because the unit will get canceled out in the equation. Learning check number 1. In a titration, 5 milliliters of 2 molar NaOH solution exactly neutralizes 10 milliliters of HCl's aqueous solution. What is the concentration of HCl aqueous solution? Pause the video and resume once completed. In this question, we're solving for the concentration of HCl. We have to use the titration equation. We plug it into the equation. We get Ma to be 1 molar. Learning check number 2. Which process is used to determine a concentration of an acid? Pause the video and resume as completed. The answer is choice 4, titration. Learning check number 3. The diagram below represents the meniscus on an acid and a base Buret at an endpoint of a titration in which 0.1 molar NaOH was used to neutralize an unknown concentration of HCl. If the solution level in each Buret was 0 milliliters at the start of titration, what is the molarity of the unknown HCl solution? Pause the video and resume once completed. The first step is to figure out the volume of acid and base used during the experiment. By reading the Buret, the volume of acid used is 0.9 mL. The volume of the base that's used is 1.2 mL. Next, we plug into the equation. We're solving for the molarity of the acid. By using a calculator, we get the molarity of the acid to be 0.13 molar. Answer is choice 2. Let's look at this example. What's the concentration of a solution of sulfuric acid if it takes 30 mL of sulfuric acid to completely neutralize 25 mL of 0.1 molar of sodium hydroxide solution? This question is not as straightforward as it looks, because sulfuric acid is a polyprotic acid, while sodium hydroxide is not. If you write out the chemical equation, you can see this much more clearly. In the chemical equation, in order for sulfuric acid to be completely neutralized, 1 mole of sulfuric acid must react with 2 moles of sodium hydroxide to produce water and the salt. So we need to account for the mole ratio between sulfuric acid and sodium hydroxide in our calculations. There's 2 methods of solving this. The first method is using stoichiometry, which we learned last term, and the second method is a modification to the titration equation. Let's look over this first method first. Since we're given the volume and the molarity of sodium hydroxide, we can calculate the moles of sodium hydroxide used in the neutralization reaction. Next, we set up a mole ratio between sodium hydroxide and sulfuric acid. It's a 2-to-1 ratio, and then we solve for the moles of acid that was neutralized in the reaction. Now that we calculate the moles of the acid, we can solve for the molarity by dividing it over the volume in terms of liters. So the molarity of the acid is 0.042 molar. Even though 2 moles of base is needed to neutralize 1 mole of acid in this example, the pH will be 7 after neutralization since it is a strong acid, strong base neutralization. For method 2, here's the modification to the titration equation. We added a new variable C. C represents the number of active hydrogen ions and hydroxide ions in the substance. For sulfuric acid, the C value will be 2. It has 2 active hydrogen ions because it's polyprotic. For sodium hydroxide, it is monoprotic, so it only has 1 active hydroxide ion. Next, we plug into the equation and we're solving for the molarity of the acid. We get 0.042 molar, which is the same answer as the first method. So you can use either method on the exam and on the Regents. Learning check number 4. How many milliliters of 1 molar NaOH are needed to exactly neutralize 100 mL of 1 molar H2SO4? Pause the video and resume once completed. So we have to use the titration equation. The C for acid will be 2 for sulfuric acid. The C for the base will be 1. We plug into the equation and we're solving for the volume of the base. we get 200 milliliters. Learning check number 5. How many milliliters of 0.6 molar of sulfuric acid are required to exactly neutralize 100 ml of 0.3 molar of barium hydroxide? Pause the video and resume as completed. So we have to use the titration equation. The C for the acid and the base is 2. We plug it into the equation and we're solving for the volume of the acid and we get 50 milliliters, choice 2. Learning check number 6. 1 liter of 2 molar LiOH will completely neutralize 1 liter of what? Pause the video and resume as completed. Using the titration equation, lithium hydroxide, which is a base, has a C of 1, while sulfuric acid has a C of 2. So you're looking for an answer that has the same amount of moles as 1 liter of 2 molar LiOH, so the best answer is choice 1. We're going to look at 2 more examples. How many milliliters of 0.2 molar of hydrochloric acid is required to neutralize 100 ml of 0.8 molar of KOH? So in this question, both the acid and the base are monoprotic, so C is 1. We're going to use the titration equation on table T. We're solving for the volume of the acid. We plug into the equation, and we get the volume as 400 milliliters. Let's look at question 6 in your packet. Calculate the mass of ammonium needed to neutralize 30 ml of 2.5 molar solution of HNO3. We know at neutralization, moles of acid is equal to moles of base. So let's first solve for the moles of acid using the molarity equation. We know molarity times volume gives us moles. 2.5 molar times 0.030 liters gives us 0.075 moles. So at neutralization, we have 0.075 moles of both the acid and the base. To calculate the mass of NH3 for moles, we need the GFM of NH3, which is 17. So 0.075 moles times 17 grams per mole gives us 1.275 grams of NH3 needed to neutralize the acid. Learning check number 7. What is the mass of HCl used to neutralize 1.5 liters of 2 molar NaOH? The GFM of HCl is 36 grams per mole. Pause the video and resume as completed. So first we have to figure out the moles of the base because at neutralization, moles of acid is equal to moles of base. Molarity times volume gives us moles. So 1.5 liters times 2 molar gives us 3 moles of NaOH. So at neutralization, we also have 3 moles of HCl. So 3 times 36 gives us 108 grams. So the answer is choice 3. This concludes the video lesson. Remember to do the Juniper homework and quiz.